Hey guys, and welcome back to another video. So in this video we are going to start a new series, that is we are going to cover the topics that consists of your trees, graphs and questions related to that. So let's get started with our first topic. So this would be just a brief idea of how your entire data structure works, and in further videos we are going to talk about the theory less, as well as we are going to do the problems and the implementation part more. So the theory part is, I suppose you know, or you would be learning that, but for now we would be focusing main on our programming part. So let's get started. So basically, what are trees? So tree is basically a kind of a non-linear data structure in which items are arranged in a hierarchical fashion. Okay, so here you can take example of your family tree, say such as see grandfathers, then fathers, and then their children. So basically, this node is referred to as the root node of a tree. Okay, that is the basic building block of a tree is a root node, and thereafter comes its child nodes, that is 2 and 3 are children of 1, whereas 4 5 6 are the children of 2. So 4 5 6 would be considered as siblings. Okay, because siblings are the parents children of the same parent. And 9 and 10 as well as 11, these are your leaf nodes, because they are at the edge, they are at the end of this tree, so they are referred to as your leaf nodes. Okay, so one thing to remember is that all these, that is these 1 2 3 4 5 6 etc., are known as, these are called as vertices or vertex. Okay, and these lines coming through this are termed as edges. Okay, so I'm denoting E with edge and V with vertex. Okay, so one thing that you need to remember is that how many number of vertex would you have in a tree. The edges would be one less than those. Say for example, here we have 11 vertices now, 1 2 3 4 5 6 7 8 9 10 11. So if you count the number of edges here, you would be finding 10. See, 1 2 edges, 3 4 5 6 7 8 9 and 10. So if a tree has n number of vertices, then it would be having n minus 1 number of edges. That you should understand. Okay, so same is written here also. The number of edges, that is if there are n nodes, so n minus 1 would be the edges. Okay, so basically, what is the depth and height of a tree? So depth of a node x can be defined as the length of the path from the root node to the node x. Okay, for example, let us for an instance say that um, we are to find the depth of 4. So we start from the root node and count the edges that come up to this 4. So this is the 1 and this is the 2, so this is the depth. Okay, and basically all these are all these nodes of a tree are located at some levels of uh, our data structure, that is it is at level 0 in our tree data structure, this is at level 1, these are at level 2, and this is at level 3. Okay, similarly for the height also, basically the main difference between your depth and height is that is the height is the longest path from the root node to a particular leaf node. That is, if we traverse from our root node um, till the leaf node, this would be your depth. or you can say that this could be your depth. I am sorry, this could be your height. Okay, so this would be your height. Next we are going to talk about binary tree. Okay, so now this is also important and an interesting topic, that a binary tree would be having at most of a two nodes. Okay, that it might be having 0, 1 or 2. So see here, binary name itself suggests that is 2, that is 0 and 1, as is the language that is understood by the computers. So basically in a binary tree, each node can have at most two child nodes. That means at most means whether it can have 0 nodes, 1 node or 2 node. So here is a demonstration of a binary tree. How it is a binary tree. See, it has maximum of two nodes, 1, 2. Same for this also. It has only one node, it has only one node to it. So this is also binary tree. Okay, say let us say for an instance you are given with only this node, and you are asked that whether it is a binary tree or not. So yes, that would be a binary tree. Why? Because it is having 0 children, then also it is a binary tree. And if it was having some kind of this, then also it is a binary tree, and then so it is a binary tree also. But if you do this, then this is not a binary tree. Okay, so simple, no rocket science type of thing here. Now let us move to the applications of the tree. So basically, why are we studying trees is because storing a natural hierarchical data. Trees are used to store the data in a hierarchical form. So what is the use of that? So if you have heard about the Linux or the Unix file system, that is basically based on your tree, that is the data or the files items that are stored in that operating system is in the form of a tree formation. Okay, the file system stored on the disk drive, the folders, etc., that is in all in the form of trees, and they help us to organize data, efficient insertion, deletion. So this also does. There is another data structure, that is a trie data structure, that is it is used to store a dictionary, that is and also helps us for dynamic spell checking. We would be learning about heap data structure. You have heard it most often. Binary tree, sorry, b trees. So basically it is used in databases and routing tables that are used to store the data in the routers. How the algorithms works, we would also be discussing all in the further coming videos. So now um, here is your implementation of a tree. So see how to create a tree in Java. So basically, in order to create a tree, you need to have a class. Okay, you might name it node, you might name it tree, you might name it anything. So see, this class would be having three properties. One would be the data part inside it. Okay, and other would be the left and right sides of that tree. So you can also understand it via form of, if we had been doing it in the form of C++. So have you studied about linked lists? So linked lists store your data in the form of, this would be your data part, this would be your previous part, and this would be your next part. It would contain the addresses. Okay, similarly you can assume of this kind also in a Java, but Java we do not have the concept of pointers, so the implementation lies to another way. So now we are having our class node. So as I told you that it would be having um, some properties. So here we are having string data, that might be int data, Okay, and we are having two further partitions of that, and these partition, that is the left side and the right side, are the part of what? These are the part of this class. So this belongs to the node class. Understood? This belongs to your node class, and whenever the constructor of this class is called, so we would be calling this data. Why? Because we have to initialize this data also. So this dot data is data, and left is equal to right is equal to null, because at the first time when we do create our tree, we were having at only the root node in that. After that, afterwards we add na data to it. So that's why, see, at first you add a to your node, but but you are not adding other nodes to it at the very beginning. At the very beginning you are defining a root only. So that's why, and the left and right, that's why these are two null. So I hope you understood about the basic overview of the tree data structure, and in the further coming videos we would be completing this code in our code editor and would be understanding how things work in your tree data structure. So till then, have a good day, and do subscribe to the channel if you haven't yet.